get out of Stellarium here. And
At this point, this is
here we go.
They're going
All right,
to be.
I think we're live. Well, welcome. My name is Drew Desker. I'm the director here at Kopernik, and it's great to have a nice crowd here this evening. Let's see here, and I apologize for all those people who've come here on an ongoing basis, but I have to do this. Who's here for the first time, or hasn't been here in a little long time? Okay. Who here are members? Okay, a good portion of the others. Especially for the people who are just coming back for the first time, or coming for the first time, or back in a while. Again, Kopernik is a nonprofit. We are we really squeeze every penny out of every dollar that we earn. But part of what we do is we have a membership, and so a Kopernik membership gets you into any of our Friday night programs for free. But also, we belong to what's called the Association of Science and Technology Centers. It's a group of a consortium of science centers throughout the country, but also even spread out throughout the world. And your Kopernik membership will get you in for free. So you could go to the Roberson Museum and Science Center. You could go to the Ithaca Science Center, or the Museum of Science and Technology up in Syracuse, or the Franklin Institute down in Philly, or the Intrepid down in New York City. And what's also nice about it is that you get to skip the long line of people buying their tickets. So anyway, a little bit of background about Kopernik. Next year we are actually celebrating our 50th anniversary as as an observatory and STEM education center. And we are planning a whole bunch of outstanding events next year. We've even managed to, as I sort of pointed out earlier, we even arranged for a solar eclipse to happen during our anniversary year. So I had to cash in a couple of cards for that. And but anyway, we're looking forward to a really banner year next year. But really, what we're all about, though, is having people get a better understanding of how the world and how the universe works. We do outreach to schools. We have programs. Actually, right now we just finished our second week of summer camps for kids that we have a range of summer camps that for kids as young as going into second grade through high school. In a couple of weeks, I'll be running a camp, a high altitude balloon camp, where these middle and high school students will build a payload. We put on a weather balloon, and then we launch it from here. It will go up over 100,000 feet, or just about nearly 20 miles high, when the balloon will finally burst, and then we'll gently come to the ground with the parachute, and our kids will go out and we'll be tracking it through ham radio and try to recover it, and then look at the video that we've taken. So we do a bunch of great things here. We always do Friday night programs from March to mid-December. We do a public program to sort of help people understand a little bit more about how the world works, or how the universe works. And then if it's clear out, we invite you to come outside and look through our scopes. We also do a thing that if for some reason you're unable to look through a scope, and you paid for your admission, we'll give you a card to come back on another night. So tonight's program is anybody out there? Let's see here. Next week is going to be a JSWT, James Webb Space Telescope update. Just about a year ago, the James Webb Telescope had their first image release. And so we are now going to sort of say, okay, what have we learned in the past year? And so Jeremy Carty, our live stream astronomer, will be here, and he will be talking about what we've learned in the past year from the James Webb. The weekend after that is our great telescope dust-off. We all know you've got a telescope or something sitting around in your garage or attic somewhere. And if you haven't used it in a while, bring it on up. Bring it, and bring whatever parts you've got, and we will check it out, help you get it cleaned up, and show you how to use it. So those are the next couple of programs coming up. One of the other things we've been doing now is live streaming our programs. And so back in March of 2020, we had to stop all programs here because of the pandemic. We thought, okay, maybe we'll just sort of hold off for a couple of weeks until this thing blows over, and well, that didn't quite work out. We started live streaming because we had these speakers already lined up. And the reaction that we've gotten from people was so positive that we've just continued to do that. So even though we have people here live, we've got people watching from literally around the world on our live stream. We actually have over 13,000 subscribers. So if you're unable to make it on a Friday night, you can always plug into our live stream. And even if you can't plug into our live stream, go to our YouTube channel, because all of our programs are stored there. So you can catch this program tonight when you get home, or tomorrow, or whenever. So all of our programs are available there. All right, let's dive in. Tonight's program, Nicholas Davis, he's spoken here before, and his topic tonight is one I think we've been all wondering about. Is in fact anybody out there? So, Nicholas, if we'll turn it over to you, I'm going to get this started here, and if you want to turn your mic on, you're.
Yeah.
Oh, okay. You want to go to your introduction first?
Yeah.
Okay, I'm sorry. There you go. And we can-
My name is Nicholas Davis. I'm a science fiction author.
Is
and I have,
it turned on?
yeah, it should be.
There
you go.
You position.
Okay. My name is Nicholas Davis. I'm a science fiction author, and I have written 15 books, including a science fiction series and a fantasy series. I have a paralegal degree and some courses at Morrisville College of Journalism. I started writing professionally in 2014, but I've had an interest in writing all my life. I also maintain and monitor a website for local authors, as well as belong to a local touring group called the Wandering Wordsmiths. Oh, does it go down? I'm the son of a Protestant minister and one of 8 kids. I was married to my wife for Nancy for 20 years. She just passed away this last March. And I have a 29-year-old daughter, Kelly, who's with me tonight from previous marriage. Tonight we'll be talking about the search for life in the universe and the solar system, and some other interesting things. We'll discuss the building blocks that are necessary for life, new methods used to search for life, and whether life is possible anywhere else besides Earth. Oh. Now I gotta go to the other one. Yeah, sorry. All right, tonight it's is anybody out there? Search for extraterrestrial life. Oh, what am I doing wrong? Oh, there it goes. Nope, that's not it. Drew, where'd you go? All right, well, you just click on it. There you go. Since the beginning of time, man has often wondered if he is alone in the universe, and if Earth is all life has to offer. Ancient civilizations prayed to the sun gods, such as the Anunnaki and the Ra, and early astronomers made assumptions what other worlds might be like based on their appearance in the telescope. Mars was once believed to have canals with running water, which a civilization thrived around. Many science fiction authors based their stories on this theory. It wasn't until recently our surveyors were able to examine the red planet in detail and discover it once contained a shallow ocean on its surface. It was always assumed through literature and the media that if there were alien life in the universe, it must be hostile towards us, and with the sole purpose of invasion. UFO sightings before and after the Roswell incident in 1947 sparked a renewed interest in the theory, but no tangible proof surfaced, even after UFOs had been spotted over the Capitol in 1952. The Roswell incident and the sightings of Mount Rainier changed the way we look at alien life, especially in our own culture. After Einstein's theory of relativity, the common man in Hollywood began to believe that maybe faster than light travel was possible after all. How else could they travel such great distances through space and time? UFOs began to appear everywhere, as they still do today. And we are no closer to finding the truth than we were in 1947. The terms flying saucers and little green men came about, even though most of the sightings were what most people describe as grays. As interest in space grew, so did man's quest for knowledge. After Sputnik launched, the space race began, and scientists everywhere began to realize that maybe there could be life out there if we only knew where to look. Space exploration had centuries or even eons to catch up with the imagination of science fiction authors, however, who dreamed of reaching stars in a matter of months, weeks, or even days. Another favorite staple in science fiction are cryoships or generational ships, which are still centuries from development if they are ever possible at all. Fusion and light sail ships may indeed propel us to near 99% of the speed of light, but even at that speed, it would take 4 years to get to the nearest star and 4 years to get back, at which time on Earth nearly 50 years will have passed due to time dilation, and astronauts will only have aged 8 years. So if we can't go there, how will we find life? One way is to send radio signals, which we started sending in 1895 when Marconi sent the first message across the Atlantic. From there, we began to send television signals and soon built satellites capable of beaming messages back and forth to Earth from space, and from space to Earth from other planets and other probes and spaceships. The Arecibo transmitting telescope in Puerto Rico was built in 1974 and was the first transmitter to send a signal directly to space in search of extraterrestrial life. It was also the site of the WOW signal, which to this day hasn't been repeated. Some of the fundamentals of life in the universe. All life comes from dead stars. As we did, we came from a supernova billions and billions of years ago. All life comes from carbon-based organisms. You must have water in some form for life. All habitable planets must have an atmosphere, and all planets must have some protection from radiation, such as the Van Allen belt. So, some of the suns, some of the stars that are out there, you've heard on Star Trek they classify M and K planets and things like that. And the life capability of stars is, well, part of that got cut off for some reason. Oh, how do you go back here? I'm screwing up. Yeah, okay. One more. It seems like that got, it's smaller. I don't know what happened with that. But yeah, it's the blue stars and the white stars are usually brighter and hotter stars, so they tend to burn out quickly, and most of them are uninhabitable due to their lifespan. And the smaller suns, like the yellow suns, the orange suns, the red suns, they're habitable if they're not tidally locked. And why are there no green stars? Well, because the black matter of the universe doesn't allow the color of green. It only green would end up being red because of the spectrum. And some of the white and red dwarf sun capabilities. The sun is usually the size of Earth, and the planet is usually closer than half of our distance to the sun. They're usually tidally locked, one side facing the sun, one facing away, and they're most likely dead planets with little or no atmosphere and temperature extremes. If the planet does fall in the habitable zone and has an atmosphere, life would most likely be in the region in between the light side and the dark side. Some of the types of planets are super Earths, which are like our own but only larger. Rocky or ice worlds like Pluto. The next ones are like water worlds like Enceladus and Europa. And then you have gas giants like Jupiter's and Saturn. The Transitory Exoplanet Surveying Satellite, or TESS for short, and the James Webb Telescope have allowed us to look deep into the past to tell how our universe is formed and how it is located over 100 potential worlds where we hope to someday explore, if not actually by going there, then through our earthly observation. One of these worlds discovered is TO1 700D, only 101.4 light years away, like it's right next door. and it orbits a Class M star, which is smaller than our own, but the planet is closer to the habitable range and mild enough on its surface for liquid water. The new James Webb Telescope is capable of detecting water and biomarkers with the planet's atmosphere. Every planet we discover brings us that much closer to knowing if we are alone in the universe or not. NASA predicts by 2050 we will find some form of biological life, even if it's just microbes. The tardigrade, or water bear, is a microscopic eight-legged animal that can live in extreme conditions, including space itself. Discoveries like these lead us to reevaluate what life may be like on other worlds. It also helps us to solve the Fermi paradox, which asks the question, why haven't we found aliens in a vast universe with billions of stars and planets? Well, one of the reasons is the vastness of space itself. If we send any radio signals from Earth at the speed of light, the message would still take millions of years to reach another galaxy, or even our closest star, it would take 8 years to get there and back for a message. And in most of those, any planets that are that far away, you would need warp drive capability, or you would know how to stabilize wormholes. That's the only way you could get there with a reasonable amount of time. Number two, any civilization before us could be long dead by now. We've been around for maybe 15,000 years. There could have been a civilization before us on another world that was around 100,000 years and died already, and it's already long gone. We haven't searched long or hard enough. I think it was the astronomer Dyson. He was talking about a glass of water. If you look at a glass of water out of the ocean and you don't see any fish, does that mean there's not any fish in there? No, it doesn't mean that. And basically that's where we are with the universe. We've only sampled a glass of water out of the whole universe, so we really don't know the answer to that yet. Or they just aren't interested in us. They may be so advanced and we may not be worth their time to even investigate. Frank Drake, who was an astronomer back in the 1930 to 2002, he was an astrophysicist who came up with an equation to help find life on other planets. I'm not going to go through the whole equation, but I'll just go through what the components are to it. One of them is the number of planets which communication might be possible. The other is the average rate of star formation in our galaxy in a year. The third one is the fraction of those stars that have planets around them. The average number of planets that can potentially support life around those stars. The fraction of those planets that have developed intelligent, civilized life. And the fraction of civilizations that produce technology that releases signs of their existence, like radio waves or light transmissions or anything like that. And the length of time such civilizations have existed. One of the parts of this equation is closer to an answer by using the technology we have today. Using tests in the James Webb Telescope, we can at least guess some of the numbers of planets around some stars, and the probability of us ever being able to figure out the entire equation is next to none, because the variables are still unknown. Most major astronomers agree that the odds are less than 1 in 10 billion trillion. But what about our own solar system? Could the authors of science fiction be right? Could there be life just a stone's throw away? Both the moons of Saturn, Titan and Enceladus, contain some interesting features worth looking at. Titan has a frozen water surface with methane lakes and rivers. It contains within its composition the organic building blocks of life, indicating as the sun gets hotter, it may become inhabitable, but only for a few billion years before our sun dies. This is likely too short a time for any life to develop here, but we may someday have the ability to colonize this moon as well as others. Enceladus is a tidally locked, frozen moon which sends water plumes 6,000 kilometers into space, indicating geyser activity under its surface. It is believed to have an ocean under its ice sheet and warmer temperatures with organic materials. It could be a breeding ground for life. It is also the only moon in the solar system to contain all the elements essential for life. Europa, which orbits Jupiter, is also tidally locked and contains a warm ocean under its frozen surface. NASA will be sending a probe there soon to see just what kind of life might be under the ice. Someday we will hope to colonize the moon, Mars, and beyond, but to do so we have to conquer some major obstacles first. There is no air on the moon or Mars, and Mars has a very thin CO2 atmosphere, unable for us to breathe without oxygen. We would have to produce it somehow on a continuous basis on either spot. And the radiation level on both of them are deadly to humans, so we would have some shielding of some kind, such as polyethylene, or live within the lava tubes and protect us somehow that way. The weather temperatures on both are very extreme. Climate, you would need climate-controlled suits or climate-controlled environment. The lack of water would cause us to extract it from polar ice caps. If we hope to survive as a race in the stars, we have to get past some of our problems at home first. Poverty, overpopulation, war, and climate change. But what about the hazards we don't see coming? Asteroids, comets, gamma ray bursts, coronal mass ejections, and even black holes all pose a threat to our world, and we have no technology today to be able to detect any of them in time. Even if we don't leave this planet, our sun will become too hot for us to live here on Earth. In less than 1 billion years, the surface temperature will be over 200 degrees, way too hot for humans, and all water will boil and evaporate. Some of the questions that we're left with are, what if life is truly precious and rare in our universe? Well, it changes our perspective of the future. We'll have to take better care of our environment and our own planet, and if we hope to live on as a race and colonize our solar system, if we continue, because our sun will eventually die. And what is the probability of life in the universe? As you can see from the Drake equation, it's very slim. And what is the probability of intelligent life other than us? It's even slimmer. And that is my presentation. Thank you. And I will answer any questions if you have them. Yes. That would be like our moon. It's one side is facing the sun, the other side's away from the sun. Yeah. Any other questions? Yes.
Are you familiar with like other methods separate from the Drake equation to try to put a number on the probability of life?
No, I'm not familiar with any other ones. No. They do like analyze on, with Mars. They're trying to do like the soil samples and try to figure it out that way. But yes.
So, what are the possibilities of silicon-based life? Because silicon is the closest molecule to carbon.
Well, I wouldn't rule it out, but I don't really know of any form of life on Earth that's based on silicon. No, no. So, yes. Yes, yes. That's when they found a signal that wasn't like normal signals. It was a radio burst, but they can't explain what caused the radio burst. Sometimes quasars cause them, pulsars cause them, but that particular one, they never found out what caused it. Yes. Well, I don't know exactly where it came from, but I know it's from deep space. It was somewhere out of our galaxy, I believe. Yes. Yeah, that's true. Yes. Yes. That's where they first dubbed the flying saucers. The pilot saw the disc flying across the mountain, and he said it's just like a saucer skipping across the water, and that's where they got the term flying saucer. Any other questions? Yes.
Where do you think the popular image of the pop culture alien came from?
I would have to say from Roswell. With the gray alien came from Roswell, but aliens have been around for, as far as in literature, they've been around a while, because H.G. Wells wrote about aliens. There were other writers who also wrote about aliens back then. So ever since you were able to look into a telescope, man has often wondered about, are we alone, and if there are other aliens somewhere in the universe. So.
They're based what they write on their own imagination, though, right?
Right. Yes. Yes.
You see any sci-fi authors that are influences on you? Anyone you like?
Oh yeah, I love Isaac Asimov. I like all the old guys, Frank Herbert, Ray Bradbury. They're all my favorites. So, any other questions? Okay, I have books in the back if anybody wants to buy them. And I'd like to thank everybody for coming. And hope you enjoyed it.